Okay, here is problem 3. This is a no calculator problem. So we're going to be using our unit circle on this one because we've got a sine function. Okay, so the shaded region is enclosed by the curve of S, the x-axis, and y. Solve this little puppy right here for x. Okay, so I want to try and get the sine x by itself. So I'm going to minus 6 from both sides, and I get 6 sine x is equal to 0. So then I have 6 sine of x is equal to 0. I'm going to divide both sides by 6, because that's 6 times sine x, and I'm left with sine x is equal to 0. So on my unit circle, make myself a unit circle, 0, sine of, where is sine equal to 0? So sine, remember it goes cosine, sine, so that's the y value. So where is the y value equal to 0? The y value is equal to 0 right here at 0. So this would be 0, 1, 0. Okay, so right there x is equal to 0. But also it's equal to 0 over here. This is negative 1 comma 0. So it's at 0 or pi. Okay, that's where this guy is equal to 0. It's equal to 0 at 0 or pi. Because if I did sine of pi, I'd get 0. 6 times 0, 0, 0 plus 6 is 6. Or if I put in 0, I would get sine of 0 is 0, 0 times 6 is 0, 0 plus 6 is 6. So I actually have two answers. X is 0 or pi. Okay, for the next one, same idea. I want to solve this, so I'm going to minus 6 from both sides. I get 6 sine x is equal to negative 6. Divide both sides by 6. I get sine of x is equal to negative 1. So again, using my unit circle, where is, for what value of x is the sine negative 1? So for which angle is the sine, that's the y value, equal to negative 1? That would be down here. This is 0 comma negative 1. That's my sine is equal to negative 1. So what is that? This is pi over 2, 2 pi over 2, 3 pi over 2. So x is equal to 3 pi over 2. Okay, so that's important because that is where my function here, this function right here, is equal to 0. That's the x-intercept. So we needed this because we needed to know where does this graph come back down and meet the x-axis. Where's my x-intercept? So that is at 3 pi over 2. So that is why we needed that. Okay, this one wasn't really all that important, but this one we really need for what we're going to do next. Okay, write down the exact value of the x-intercept of f. Oh, that's what we just found. So the exact x-intercept is going to be equal to 3 pi over 2 comma 0, or you could just write x is equal to 3 pi over 2. Oh, and this was a typo, okay? It's between 0 and 2 pi, same as what it said up there. Sorry about that. Okay, the area of the shaded region is K. Okay, K is equal to the area of the shaded region. To find the area underneath the curve, we're going to integrate the function 6 plus 6 sine x. And we're going to integrate it from where the shading starts to where it ends. So that's from here at x equals 0 to x equals 3 pi over 2. So I'm going to go from 0 to 3 pi over 2. Find the value of k, given your answer in terms of pi. So that's why this is a non-calculator problem, because we're not going to actually finish it. Okay, to write this correctly, I'd put that in parentheses and write dx. Okay, so I need to integrate this. So I'm going to integrate the first part. 6 becomes 6. Oh, should I be doing x? Yeah, we are using x. Okay, so if I integrate that, 6 becomes 6x. Plus, we keep the constant, and when we integrate sine, we get negative cosine. And that's going to be from 0 up to 3 pi over 2. Okay, now we need to substitute these values in. So notice this one's 0, but be careful. You do want to put it in and make sure, see if the second part of the equation actually disappears or not. So I'm going to go ahead and do my substitution, starting with the bigger one. So it's going to give me, k is going to be equal to 6 times 3 pi over 2. And notice the negative sign here. I'm going to move it to the front. So that's going to be minus 6 times the cosine of 3 pi over 2. Okay, so I substituted that here and here. And then that's going to be minus, now I'm going to do it with the 0. So 6 times 0 plus 6, oops, sorry, I was changing that to minus. Minus 6 times cosine of 0. Okay, so if I do this first part, let's see, I can reduce 6 over 2 is just 3. So 3 times 3 is 9. So I get 9 pi. And then cosine of 3 pi over 2. Okay, so 3 pi over 2 is over here. The cosine of that is the x value, so that's 0. Aha! This part is just 0. 0 times negative 6 is just 0. So this first set here is just 9 pi. Okay, the next part, 6 times, so minus, 6 times 0 is 0. That goes away. Okay, cosine of 0. Cosine of 0. Here's 0. Cosine is the x coordinate, so that's 1. So cosine of 0 is 1. So I'm going to have 1 times negative 6. That's negative 6. And then minus negative, this becomes 9 pi plus 6. And they said leave the answer in terms of pi, so k is equal to 9 pi plus 6. There's the answer. Okay, that is the area under the curve, right there. So I suppose we could say units squared. Units squared, just to be on the safe side. All right, give a full geometric description of this transformation. Okay, so they took our f of x and all they did was change what was inside the parentheses. And so notice that's in backwards land, and that's our horizontal shift. So if it says minus, that means it's to the right, because this is backwards land. So it moves right pi over 2. Okay? So, or you can, another way of saying that is it's translated horizontally or to the right. A bunch of ways you can say it. Okay, you can say it a couple ways. Okay, given that the integral of g of x, okay, that's our new function, also has an area of k, what are two values that we could use for p? Okay, so I'm going to go back up and look at my guy up here. This is 3 pi over 2, so 1 pi over 2 would be a third of this. So this would be pi over 2, this would be pi, and there's 3 pi over 2. So this whole thing is being shifted over to pi over 2. So if I do a little, let me get some points on here. So I'm going to shift over every point over pi over 2. So I'm shifting this over. This would be 2 pi. Okay, that ending, it's ending in 2 pi. So this would come here. So I'm shifting this over. So here's my new function. And we want to know from where to where would it give me the same area. So really one of the values as well, clearly, we just shifted it over pi over 2. So instead of starting at 0 and doing our integral from 0, well, we shifted over to pi over 2. And if I do pi over 2, sorry, I have to keep jumping back and forth. If I do pi over 2 plus 3 pi over 2, that gets me 4 pi over 2, which is just 2 pi. So that would be right here where it just ended. So one obvious answer is p is equal to pi over 2, because we just moved it that far to the right, so we would just move this guy right here. We'd move it over pi over 2. And so this one's also moving over pi over 2. Okay, so one obvious answer is p is equal to pi over 2. The less obvious answer is the second one, and I actually came up with two other answers. I was thinking if I put in, well, no, don't worry about what I was thinking. Okay, back up to here. So if I look at this area from here to here, if I look at this from here to here, this area is the same as the area from here to here. Okay, so that red area that I just scribbled in is the same as from here to here. And then this little piece over here, I can flip it back over here. See this little guy? That is the same as this over here. So if I want all of the shaded, the original shaded area, that red part, plus this piece over here, this little piece is the same as this little piece. And then this big piece here is the same as this big piece here. So I could also just go from 0 to 3 pi over 2, and I'd still get the same area as the original area, because this piece here is the same as this piece over here. So my other answer for P, which is not as obvious, would just be that P is 0. So you could integrate it along that same interval and you'd get the same area. It's just that that little tail piece has been flipped to the front instead of the back. Okay, so that's the answer to that.